This is a continuation of lesson 13. The last thing we did from the first video was write this number in scientific notation. I'm going to do a couple more examples of that, and then we're going to look at some word problems. So let's say we have a decimal number. Okay, that's got what, 1, 2, 3, 4, 5, 6 places. So that is 6 millionths. Now, the decimal goes to right of the first non-zero number. And then let's count the spaces to go back where the decimal actually is. So that's 1, 2, 3, 4, 5, 6, like we said. Now, since the decimals moved to the left, it's going to be 6, or you can put 6.0, times 10 to the negative 6 power. So for a whole number, we have a positive power because what that's saying is you're taking that number and you're multiplying by 10 over and over and over again, which is moving the decimal to the right. And then, of course, we'd have to continue, we'd have to do that 7 times to get back the 16 million. And a negative exponent means division in math. I know it's kind of weird, but it does. And so if you take 6 and you divide by 10, that gives you a decimal. Divide by 10 again, decimals moving further, and so on. Another thing you can do on this particular calculator is, for example, if I put in 16 million, and I hit my, you see SCI up there. If I hit my green button and hit that, it will give me the scientific notation. Now, you're going to have to write it like this. It doesn't show times 10 to the 7th power, and we're not calculators, so you do need to put that in there. So you could use that feature. And, of course, we can go the other way. If we're given a number in scientific notation, and they want the decimal or standard number, positive, we move to the right. So we would take the decimal here and move it to the right 5 places, 3, 4, 5, and we'll tack on zeros. So that represents 435,000. Okay. Now, finally in the lesson, we've got some word problems. I'm going to do these 3 right here, so if you want to take a snapshot and print these, or you may want to write them on paper. Let's see if we can see those a little bit better. There we go. Okay, so I'm going to be working these, so if you want to pause it right now, that would be a good time. And we'll get these solved then. Okay, this first one. The total length of 3 pipes is 86 inches. The middle pipe is 6 inches longer than the smallest. The largest is twice as long as the smallest. How long is each pipe? Well, let's just draw a visual here. We have 3 pipes. We have a smaller, a medium, and a large. And we're going to have to set up our own equation. And we don't want to use 3 different variables. That's not going to help us. What we'll do is we'll say that X is the smallest one. The middle one is 6 inches longer, so that would be the length of the smaller plus 6. The largest is twice as long as the smallest. Twice means times 2. It says the total is 86. Remember, total means addition. So if I add these together, they should equal to 86. So I've created an equation. X plus 6 plus 2x equals to 86. We combine like terms. Remember, these have an understood 1 here. So 1 and 1 plus 2 is 4x plus 6 is 86. And we'll solve that equation. So the smallest one, and this is in inches, my smaller one is 20 inches. The medium one is going to be 20 plus 6. The largest one's going to be twice that, which would be 40. And you can check this. That adds up to 86 inches. So word problems can be checked just like any other problem. So don't be intimidated by them. This next one, we have 3 tanks that have a total capacity of 600 gallons. 2 tanks are the same, and the other one is half of their size. And we want to figure out how many gallons each holds. So let's just do a visual here. So we have 2 tanks that are the same. Supposed to be the same. And we have one that's half the size. And if we add up all their volumes, we get 600. Let's let these 2 that are the same be X. And this one's half, so that would be 1/2 times X. So our equation these are understood ones. If I have a half, I just soon work with a decimal. We can think of this as 0.5x. So 1 plus 1 is 2, plus 0.5 is 2.5x. We divide. And let's see what we get here. 600 divided by 2.5, 240 gallons. So these 2 here would be 240 gallons each. And that would be 240. And half of 240 is 120. And if you add that up, all that adds up to 600. And this last one here. We have partners in a catering business. And one of them receives 1/3 more than the other when they get their profits. And there's their profit. So we have 2 partners, Eric and Hannah. And their total profit, $85,400. Okay, now Eric gets X number of dollars, and so does Hannah. But he gets an additional 1/3 of those dollars. So he is to receive 1/3 more, so he gets a base amount plus 1/3 more. Okay, so we add the like terms, 1 and 1. That's 2 1/3 X. Now, I'm not going to change this to a decimal because if I do, I'm going to have to round it and lose some accuracy. Let's change that to an improper fraction. 3 times 2 is 6, plus 1 is 7. That's 7/3 X. And we can divide both sides by 7/3. Now remember, when you divide by a fraction, it's the same as multiplying by the reciprocal. So if I have a number divided by a fraction, I keep that number, I can just put it over 1, and I flip the one that I'm dividing by. And we can put this in the calculator. We just put in 85,400 times 3 divided by 7. And it looks like 36,600 is the base amount they're both going to get. So Hannah's going to get just the 36,600. Eric's going to get that plus a third more. To get a third of something, you can multiply by 1/3. So he's going to get that plus an additional 12,200. And let's get that, and we'll check our work. And how do we check it? These two together should give us that.